Homework question 12.36 is very similar to 12.35. Again, they tell us we have 2.7 moles of a blue fruit drink is mixed into 1.33 liters of water in a pitcher on a hot summer day. They tell us the density and they tell us the vapor pressure of that pure water, and then ask what is the vapor pressure of that solution, of the two mixed together. So again, another example of Raoult's law, which is basically our vapor pressure of the solution equals my mole fraction of my solvent times the vapor pressure of my solvent. And again, they've given us the vapor pressure of the solvent that was given in the question. So that vapor pressure of the pure solvent is 25.4 millimeters of mercury. So same as before, we need to find our mole fraction. And this time they gave us one of the moles already, the moles of the solute. So I need to find the moles of the solvent. So I've got 1.33 liters, and I know in 1 liter I have 1,000 milliliters. So I have 1,330 milliliters of water. And I know the density of water is 1 gram per milliliter. So I have approximately 1,330 grams of water. Now that I have the mass of water, I can find how many moles of water I have, because I know that there are 18 grams of water in 1 mole. So 18 grams cancel out, and I'm left with moles of water, so approximately 73.89 moles of water. Now I can find my mole fraction. I have approximately 73.89 moles of water over my total moles. My total moles are 73.89 plus the moles of my blue fruit drink mix. So plus 2.7. I get a mole fraction of approximately 0.9647. Now I can calculate the vapor pressure of my solution. So the vapor pressure of the solution equals my mole fraction, 0.9647, times the initial vapor pressure of the solvent. So that was the 25.4 millimeters of mercury. I multiply, and I'm able to find that the vapor pressure of the solution, again, is lower than my initial vapor pressure. The vapor pressure of my solution ends up being approximately 24.5 millimeters of mercury. So we had to convert volume into mass using density. Once I knew mass, I could use the mass to find the moles. That was my moles of the solvent, and then the next thing I had to do was find the total moles. Fortunately here they gave us the moles of the solute, so I just had to add those two together to get my total moles. That allowed me to find the mole fraction of my solvent, and then I could find the partial pressure of that solution, the two mixed together, solute and solvent.